Very exciting semester ahead. We'll have a quick look at our letter first. So pretty similar to last term, 3 topics. Well, actually there's 4 topics because we'll do matrices and PMI together because matrices is a very short unit. Like you'll see some of the kids in general maths doing matrices. So obviously we'll learn those basic skills and then we'll take it a little bit further. And then PMI, we're doing them together, so that's one test about that. We'll have our folio task early on. We're doing it on further trigonometry. And so a lot of the stuff we're going to start with, you've done before. Actually, not a lot of it, maybe 2 or 3 things in this chapter you've done before. And then a lot of it's going to be new, and we're taking some of the stuff we have done a bit further. When we do encounter stuff that you've done, it will be a bit more challenging. And the good news is as well, basically for all of these things here, for all those topics, we get to use the blue book. Okay, so you might remember last semester we used it for like vectors, and that was all. So this semester we're going to be using it for all of them, except PMI, for which the questions are in your work booklet. Okay, so the notes booklet here has all of the notes for all of the chapters that we're going to do. All right, and so with the printer, right, you can print a booklet. As long as it has 60 pages, it'll staple through it. Anything more than 60 pages, it won't send the staple through. So I think we checked in at 56 or something like that. So we did quite well to squeeze it in. And hopefully there is enough room throughout to fill in all the examples and that. And like, no doubt there will be a few errors because I sort of put it together in holidays. So as we're going through, we can correct it. If there's any major mistakes. I just mean with the examples, like I might have a 3 instead of a 2. Okay, so then, yeah, the test there just says 25% for all the tests, 25% for the folio. Yeah, cool. So I reckon let's get straight into it. So we're talking about the tangent function. I'm going to go through both 4a and 4b today. It's all mapped out on sector, both the first unit and probably half of the second unit. So that's the pace I sort of want to keep. We do miss week 7 because there's your retreat. Who knows where it's going to be at this stage? There's your year 11 retreat, and then there's a couple of student-free days like show days. Okay, so here we have the tangent function. We've got the graph of it on our notes book there. Okay, so it's quite different from both the sine and cos. Remember, tan is sine divided by cos. And we're asked to describe the transformation that maps tan x to y equals tan of x take 3 plus 4. Alright, so hopefully we get pretty familiar with this. We have x take 3 is moves 3 units right. And plus 4 units up. Okay, so it's moving everything across 3 units to the right, up 4 units. Okay, now the period of a tangent function I have written above is pi divided by b. Period is pi on b. And the value of b in this circumstance is 2. Okay, it's always the coefficient of x. The coefficient of x is 2. So the period is pi on 2. And what that means is we have one occurrence of the wave function in pi on 2 units. You think of the tan function, it looks like this, okay? So that means the distance between this asymptote and this asymptote will be pi on 2 units. Okay, that's what we mean by period for a tangent function. Okay, let's move on to 4b. We're given this function here, y equals minus 3 sine of 2 times x take 1. Find the amplitude and period. Okay, so the amplitude is the magnitude of the value of a. Okay, so if we're thinking about the graph of this, all right, so sine x is like that, and if we have 3 sine x, it's multiplying every value by 3, so it's giving it that vertical dilation. Okay, so it's cranking it up. All right, but this negative makes every positive value negative and every negative value positive. So the real shape it's going to have is something like this. All right, but regardless of its orientation, the amplitude is always the distance from that principal axis to a peak or trough. Okay, it's what we call the magnitude, the size of that one. So the amplitude is 3. We can't have a negative amplitude, just like we can't have a negative All right. And then the period is 2 pi divided by b. Now b is the coefficient of x. And one thing I'm going to say is when we get these ones where there's sort of these two sets of brackets, we should expand it. So this is going to become minus 3 sine of 2x take 2. Okay, and so now you can see what the coefficient of x is, but you can also see how much it's going to shift horizontally. Because it's not just shifting 1 unit horizontally, it's going to shift 2 units horizontally, and it has a period of 2 pi divided by 2, which is pi. Okay? So the amplitude is 3, and the period is pi, to answer the question here. Okay, then we have cos bx. Cos bx, we don't know what this value of b is, but it has a period of 6. So what that means, if we have the cosine function is like this. The distance from 0 to the end of one whole wavelength is 6 units. Okay? So we would know that the period is 2 pi on b. That's always the case for a sine and cosine function. We're told the period is 6. So 6 is 2 pi on b. And we'll just solve that for b. So b is 2 pi on 6, which simplifies to be pi on 3. So what's the algebra involved here? I'm multiplying both sides by b to get the b up here, and then b on this side cancels, and then dividing both sides by 6. Now my b's and my 6's look a little bit similar. So just exaggerated a bit. Okay, last one. State the transformations that map sine x onto 3 sine 2x take 1 plus 4. Okay, so what we'll probably do here is we'll go through and I'm just going to identify the values for A, B, C, D, and then next to them I'm going to make a remark about what that does. So we've got an amplitude of 3. Now what does it expand to? Let's write it in expanded form first. 2x take 2 plus 4. Okay, A is 3, B is 2, C is 2, and D is 4. Okay, so here, amplitude. Now, one of the ways we've described it, it's a good way to describe it, is that it's stretching it further away from the principal axes. Okay, the correct way, now that we're in stage 1, semester 2 specialist maths, we're going to say it vertically dilates. Okay, so that means stretching or compressing that word. Vertically dilates, and then we need to determine the scale factor by which it dilates. So it vertically dilates by scale factor, and we can just write SF, the scale factor, of 3. Okay, it's multiplying every value by 3. Okay, when we're talking about B, so the base sine function, I'll just compare it with the base sine function. The base sine function has a wavelength of 2 pi. But when we have sine, so that's sine of x. But when we have sine of 2x, okay, what that means is we have 2 wavelengths in 2 pi, or we have a wavelength of pi. So it's going to look like this, isn't it? Okay, and so what that means is it's squished it in. Okay, so we have a horizontal dilation, that's the correct way to describe it. By scale factor. Okay, now for a trigonometric function, the horizontal dilation, maybe I'll describe it here first and then I'll talk about the rule. Okay, what you can see is every value is like that point there would normally be pi. Now it's pi on 2. That point there is 2 pi, and then down here it becomes pi. So every value is dilated by a scale factor of half. Okay? What's the rule? Okay, the rule here is whatever the value of b is, so you could have sine 2x, up here we could have cos of pi on 3x, the scale factor that it dilates by is 1 on top of b. Okay, so that's an easy way to think about it. The scale factor by which it dilates by is 1 on B. And then for vertical dilation, the scale factor it dilates by is always A. Okay, so I can put that in brackets here. Dilates by A, and here it dilates by 1 on top of B. So that is going to be for both sine and cosine functions. Okay, C, we've got 2, moves 2 units right. Right because it is take away C, and then 4 units up. Okay, so nothing absurdly different from what we've done before, but just really focusing on getting that language correct now. Okay, so we've also got, like, you see the checklist at the start there. So that's what we're today we're going to go through 4A and 4B. So let's get into that.